How do some tissues regenerate in anatomy? Have you ever wondered how our bodies heal after an injury? The process of tissue regeneration is fascinating and varies across different types of tissues. Let's break it down. Tissue regeneration refers to how damaged or lost tissues are replaced by new tissue. This process restores both the structure and function of the original tissue. The journey of regeneration includes three main phases: inflammation, repair, and maturation. First, when an injury occurs, the body triggers an inflammatory response. This response helps clear away damaged cells and any pathogens that may have entered. After this initial phase, the repair process begins. Cells start to proliferate and migrate to the injury site, working hard to rebuild the tissue. Finally, the maturation phase involves remodeling the new tissue to regain its strength and functionality. Different types of tissues have unique ways of regenerating. For instance, epithelial tissues like skin regenerate through the movement and multiplication of skin cells called keratinocytes. These cells come from the edges of the wound. Additionally, fibroblasts in the underlying layer help by producing proteins that support the new tissue. Over time, the new skin may form scar tissue, which is often less elastic than the original skin. Muscle tissue has its own regeneration process. Skeletal muscle fibers can survive injuries in fragments. There are special cells called satellite cells that activate when there is damage. These cells multiply and fuse to either create new muscle fibers or repair existing ones, helping to restore muscle function. Nervous tissue regeneration is a bit more complex. Peripheral nerves can regenerate through the regrowth of axons, but if neurons are severely damaged, they may not survive. Glial cells and supportive connective tissue play a role in guiding this regrowth. However, regeneration in the central nervous system is limited due to various challenges. Some organs, like the kidney, have a limited ability to regenerate. After an injury, surviving cells in the kidney can migrate and revert to a less specialized state. They then multiply and eventually return to their original function. This process involves kidney stem cells, which are still being studied for their roles in regeneration. At a cellular level, regeneration can involve several mechanisms. These include the activation of resident stem cells, replication of mature cells, and even transdifferentiation, where one mature cell type changes into another. Molecular signals, such as growth factors, are essential in regulating these processes, promoting cell movement and growth necessary for healing. Understanding how tissues regenerate helps us appreciate the body's dynamic nature. It shows how our systems work together to maintain health after injury. This knowledge is also important for developing medical therapies aimed at improving healing or creating tissue replacements. In summary, tissue regeneration is a multi-step process that varies by tissue type. It involves inflammation, cell growth, and remodeling to restore function and structure after an injury.